A Promising Future for OSGi by Tim Ward. Tim is a quite well-known person in the OSGi world. He's been working actively in the different expert groups. And last but not least, he's the co-author of the book Enterprise OSGi in Action. So, welcome Tim. The floor is yours.
Well, hello everybody. So thank you all for being here. So just a little bit more about me. So I work for a company called Paramus, and before that I worked at a company called IBM, which I'm sure you'll all have heard of. I've done lots and lots of stuff in Java EE, but I've also done lots of work with the OSGi Alliance trying to get some bits of Java EE maybe working a bit better, or in some cases working at all. I do a lot of work in the Apache Aries project, and I speak about the stuff that I do quite a lot. And as you've already heard, I'm a co-author of Enterprise OSGi in Action, and you're quite privileged because the other author is in the back just there, and it's not very often you get both of us in the same place. So what we're going to talk about today is a bit about why the world is going asynchronous, something about some async programming primitives, how we can take existing synchronous services and make them more asynchronous, and then a bit about how we can do some optimization there and we can really get these things flying along using async rather than sync programming. And then, although I know the demo gods have not been kind to many of us so far, I am going to be attempting a live cloud demo. So just a little bit about the OSGi specs. So this is all based on R6 of the OSGi specs. So the R6 core spec was released back in June, so it's pretty new. But there are also public drafts for the R6 Enterprise spec, which should be coming pretty soon. We're kind of going into the closed down stage there. But there's a public draft which has all of this stuff in it, and we're really hoping to get something done end of this year or maybe very early in the new year. So, why is the world going asynchronous? Well, you know, what's this all about? So, firstly, we really do need to talk about the origins of async programming. So this is something people think of as being this big recent phenomenon. Suddenly, everything's asynchronous. But actually, the terms promise and future were first used in 1970s research papers. This is not new stuff. This is stuff people have been talking about for 40 years or more. And it's basically, it originated as a way of getting people to be able to cope with large-scale parallel execution, because they basically didn't know how to handle it. Nobody had ever done this before. And it, as I say, basically, it's been there for a long time. So any of you who've done UI programming know that little spinner you get, and that's what happens when you block the UI thread, because you've got this one thread that can do the updates, and if you do work on it, then you block anyone else from being able to update the UI. So async has been around for a really long time. UI programmers know it, but it just seems the enterprise is finally catching up. So realistically, the reasons that we choose to do async programming are because it gives us some advantages. One of them is it does give us better performance, although that does assume that you don't have a bottleneck of disk access or CPU already, because if you're already maxing that out, then I'm sorry, async's not going to help you. You know, you don't magically get more CPU power than you had before. You also typically get better scaling, because you're not spending time waiting for things to happen. So if you've got a long, high latency call, then you can do something else in the meantime. And you also tend to get better failure characteristics, because you don't end up locking up a whole part of the system while another part of the system then can't do anything, and effectively you just see the system deadlock rather than actually some part of it isn't working but other parts of it are, and you can reason about why. And parallelism is easier to exploit. If you're doing things asynchronously, you're already intrinsically multi-threading, and you're doing things with, you know, oh, I'm going to do this while this is happening. So it's kind of nice that way. And just as an aside, network infrastructure has worked this way forever. Networking is intrinsically asynchronous, and you know, network engineers, when you talk to them about this stuff, they say, well, sure, how else do computers work? So the problems with async programming are really humans. humans don't get asynchronous logic very well. We have thought processes, we're designed, I'm swinging through the trees, I'm going to leave with this arm and I'm going to grab for that vine, and then when I'm holding onto that vine, I'll be able to reach the next branch. It's not a case of what I'm going to do is I'm going to fly through the air and grab onto that branch, then I'm going to grab the vine that was in the middle, oh wait, I've fallen. So async, not how thought processes work, because that's not how we evolved. So it's only going to be useful if we can make the async programming, the benefits outweigh that cognitive overhead. We need to make sure that people understand what's happening and can use it without having to completely break their normal thinking. You also have the problem that actually, so synchronous programming, you've got this kind of natural break. So it will slow you down if you start going too fast. Whereas async, no, I'll quite happily use a single thread on a client and totally overwhelm a server without even realizing I'm doing it. So you've got to be really careful with async systems, because some of the things that we just kind of get and take for granted just aren't there anymore. And you can still deadlock things. And when you do deadlock things, it can be pretty difficult to work out why it's deadlocked, because effectively what will happen is everything will look fine, you just won't get any callbacks. And that can be a real pain to try and work out what's going on. So the question is, what's changed? I've said this thing's been around for 40 years or more, but suddenly everybody's talking about it. And one thing is multi-core. So 40 years ago, there weren't really multi-core, multi-CPU systems in the way that we have them today, in that this thing has 2 cores. Most new ones have 4 cores. And this is just something I keep in my pocket. So suddenly we're in a position that parallelism is something that you can exploit on even really small devices. So you've got to think about them in a new way. We've also got OO languages becoming more functional in style. So suddenly we've got lambdas in Java and C++. You've got all the functional languages that people are using elsewhere. And those things lend themselves better to an async style. And you've got JavaScript. And it's been a huge driver basically because it's a single-threaded environment. And if you don't do stuff asynchronously, then it's not really going to work. So you've got this huge number of toolkits that all have different async stuff, but JavaScript has been a big driver of this. So we need to talk a bit about async programming primitives. I kind of mentioned the terms from these 70s research papers, but we need to know what these things are. So effectively, you have this thing called a promise, and the promise is pretty much the primitive. You've got bytes and shorts and ints. Well, in async, you've got the promise. And it's basically just a delayed value. And you know that at some point in the future, this promise will be resolved. And that resolving is just setting its value, or a failure, because these things don't always work. So the OSGi promises that are being introduced are heavily based on the JavaScript promise, but they also have been influenced a lot by the stuff in Scala. So if you have used either of these before, then a lot of this will be very familiar. Strictly speaking, and I'm just being technical here because I have had people ask me before, OSGi and most implementations of JavaScript promises aren't promises, they're futures. Because a future type is one that you don't have the resolve method on it, whereas the promise does. But we thought that we'd probably upset a lot of people if we created another type called future in code that a lot of people will want to use with Java util concurrent future. Because I don't know about you, but I really, really hate it when I've got 2 types of the same name that need to be used together a lot. So that's the main reason they're called promises, and also because of the link with JavaScript promises. So, as I said, in both cases for JavaScript and OSGi, there's this thing called a deferred, which would be more strictly called the promise type, and that's the thing that you can resolve. So, promise contract. A promise is resolved or failed with a single value at most once, meaning you're not going to get lots of values coming through it. Once it's resolved, and it can fail or it can resolve with a value, but it can't do both. Listener callbacks are called at most once. So when you resolve, any listener callbacks will be called, and then they won't be called again. So you don't need to worry about what happens if I get, it saying it failed, and then it failed again, and then it failed again. It won't do that. You'll get called once. And a promise remembers its state, including this resolution and failure value. And therefore, they can behave the same way regardless of whether it was resolved before or after you registered your callback. It doesn't matter whether the promise is already resolved. If you register a callback, it will either call back immediately because the thing's already resolved, or it'll call back in the future when it resolves, and it doesn't matter which. So you can treat a promise as a shareable value type, and this is really important. You can actually give it to someone else, and they can use it, and they don't need to worry about how old it is. It won't go stale, because this thing is thread safe, and it's effectively immutable. I say effectively immutable because you can resolve it, at which point it has a value and its state has changed, but actually you can't do that from the promise. You've got to be the person who originally created it and knows how to resolve it. So you've got this thing that you can pass around, and it's really useful. So I talked a bit about the deferred, and deferred you can think of as kind of a factory for a promise. So it's the thing that holds the promise object, and you can use to resolve it when you've got an answer. So we've got some code here. Figured it was about time for some code, where you can see here we're just creating a new deferred, and then we're doing some work asynchronously, hence we're starting a new thread. And effectively all we're doing is we're calculating a difficult sum, so something that's going to take a long time. And then once we've got the answer, we resolve our deferred. And if we get an exception, we fail our deferred. So then what we can do is we can call deferred get promise, and we've got a promise that we can pass around to someone, and that value they can use, and it will resolve when that sum is done. Whether that's 100 micros or 100 seconds, doesn't really matter. So promise callbacks. So I can just say quickly, promises, you can use them synchronously, just like a Java future. So you've got an is done, a get value, get failure, and basically get will block until this thing is done. Now, how many people have called get value on a future basically immediately after creating it? Oh, I think no hands are going up, which means either we don't have that many people using async or parallel programming, or there are a lot of liars in the audience, because pretty much the only thing you can do with a Java future once you've created it is you can kind of maybe just call is done a few times, but pretty much what you always end up doing is calling get value and blocking it. So you turn your wonderful parallel async system back into a synchronous one because you've got no other option. So that sucks. Don't do that. It's much better to use a promise with a callback, because as you remember from the UI stuff, we shouldn't be blocking the thread. So you've got a then method, and what then does is it allows you to register a callback that'll get called when the promise is resolved successfully, or when it's resolved with a failure. So the two instances of it, and you can pass null for the success callback if you do just want to know if it fails. That's fine. And in both cases, these things are single abstract methods, so you can actually do really nice Lambda usage like this. I don't know how many of you are familiar with Lambdas, but effectively we've just dynamically created a success callback, which is just going to recall success, which is some method we've got, with the value that it resolved successfully with. Or failure, we can call some failure method. But these things are designed to be really easy to use, and really they work very nicely with Java 8. Callbacks should be fast. Just to say, don't block. That's not what async programming is about. And the success method is actually allowed to return a promise if you want to do some longer running work in it. So that will be used to actually work out when the thing's completely done. And that's because promises can be chained. Now, this is the bit where I imagine a lot of you are maybe going to lose me. And I'm sorry about that, because this genuinely is quite a hard thing to grok. It took me a good while before I really thought, yeah, I get this now. And it's because the problem is that you've got a lot of promises involved. And I'll try to do my best, but it helps. If it helps, just read through it a few times. You will get it, and it does make sense. I promise. So basic chaining uses then and creates a new promise. And so that promise that is returned by then will resolve when either the success callback has returned null to say, I'm done, I don't have anything to give you. The success callback throws an error saying something went wrong, at which point you'll get a failure in that promise. Or if the success callback returns a promise, then when that promise resolves, the return promise will resolve. And this is where it gets complicated, because we're now talking about 3 different promises. We have the original promise, which is the thing we called then on. So that guy has resolved successfully, and he can only resolve once. So he is successful, come what may. The success callback then runs. If he returns null, then the returned promise is resolved with null successfully. If he fails, the returned promise is resolved with the failure as a failure. If he creates a promise, then this is where we go to the races, because that promise is used to resolve the return promise over here. And that's where people tend to lose it, because you've got 3 promises involved. The original one, which is successful. The one created by the success callback, which is not yet done. And the one returned by then, which was returned before we even ran the success callback, which is also not done. But when the success callback completes and the promise created by it completes, however that promise was resolved, that's how the promise returned by then will resolve. And that's the loop. So go away, think about it, it will get better. So the reason that this kind of can be a bit difficult to grok is that a promise is a monad, and you can use it to build up these flows of computation, and you can get really complicated behaviors without any if-else branching, because you've got this success and failure, and you can use the state of the promise to determine what's going to happen next in the chain without having to do branching logic. But that's why people find this thing a bit difficult to start with, because unless you've worked with monadic concepts before, they can be a bit challenging. The thing is that because we've got this, you've actually got more complicated functional chains that you can natively support, and you can do really cool things with them. So you can do filtering, mapping, recovering, and that's kind of cool. There's also a utility class which gives you some other common functions that people tend to want. So you can create a promise that's already resolved or already failed. And you might say, but why would I do that? Well, sometimes you have a value already, but you need to return a promise. Like from your success callback, it may be that you've got something you can return really, really fast, so there's no point doing all the work of setting up a new thread, but you do need to return a promise. So returning a resolved or failed promise, very handy. You've also got promises all, which is kind of a latch. And the nice thing about this is it returns a single promise representing the state of a lot of other promises. So you can say, I'm going to run 100 things and they've all got promises, but I really only want to know when they're all done. And until they're all done, I don't care. So you can use promises all, and you'll get a single promise, and you can register for a callback when everything is done. Really good for the final cleanup, or if you've got some aggregate task and you want to notify the user, yep, we've finished provisioning your cloud server box, that's the way to go. And remember, these things do work even if your promise is already resolved, because that's in the promise contract. It doesn't matter whether the thing is resolved before or after. You can register a callback and it will get called. So I talked about chaining and this mapping stuff. So let's do a quick example. So we want to download an XML file from a mirror URL, and then we want to parse the content using JAXB. Now, I haven't used a smaller font than I have elsewhere. Anyone care to guess how many slides this goes on for? So you can get this whole thing there. Because what we can do, and so I've cheated a little bit, the implementations of get mirror and download file are just there, but the full logic we've got here, pretty simple. So we get hold of a mirror for our library URL, which is going to return a promise, because it might take a little bit of a while to work out the best mirror based on location or whatever. But if that fails, we fall back to just using the original URL, because you don't need a mirror. Then, once we've decided whether we're using the real URL or the mirror URL, we're going to download the file, and we're going to download the file using the value of the promise. Then once we've downloaded the file, we're going to map that file into a JAX-B object. Really simple. And this is the kind of stuff that you can do once you adopt a more functional monadic style. You've got all of that logic, which previously would have been a load of if, do this, maybe loop over a load of stuff. This is, in many ways, much more elegant once you get the hang of what it's doing. So that's promises. That's kind of the async primitive that we absolutely have to have. And that's something that is being produced by the Alliance and actually has no dependencies on any of the rest of the OSGi framework. So even if you decide that you never want to see OSGi again, I would keep the promises, because you don't need the framework. You can just take them, drop them in as a library, and use them anywhere. On the other hand, if you do decide that you want to keep using OSGi, you'll want to be able to do some more cool things with these promises. So this is about how we can take an existing service and make it asynchronous. So I'm sure you have all seen many versions of this picture over the conference so far, which is the typical OSGi, I have someone providing a service and someone consuming a service. So a service object, as I'm sure you're aware, is obtained from the service registry and then you invoke it. And obviously the call semantics depend very much on the API, but we write Java. Most Java APIs are synchronous in operation because that is the way that people have written Java for the last 20 years. So the other thing is that this OSGi service may be a transparent representation of some remote resource off somewhere. That might be done through some kind of RESTful client, or it might be that you're using remote services. You don't really know. But either way, it's still going to have almost certainly a synchronous call semantic. So the question is, as a client, how do I make an asynchronous call here? I don't really want to rewrite the service because that's not very nice. What if other people want to use it synchronously? I could double it up, I suppose, but you're talking about doing quite a lot of work there. And you don't really want to start threads or manage your own thread pool because that way madness lies. And you want your code to stay clean, and that's important because clean code is easier to read, is easier to understand. So an ad hoc solution is kind of messy, but was pretty much the only option you had. You pretty much had to break one of these things that you wanted in order to make it work. So we came up with some requirements, which is we want to allow an arbitrary OSGi service to be called asynchronously, and it should be transparent to the backing service so that you don't have to opt into this thing, you should just be able to do it. Must work with things that return a value as well as void, because async's a lot easier if you can ignore return values, but if you've got to be able to do it with pretty much any method, not just the simple ones. We're not relying on any generated source, any client local interfaces or reflection, because it gets out of sync and it's horrible. We didn't want to mess in our code, and anything which means you're falling back to reflection means you've got a mess in your code. So what do? Well, we looked at unit testing because everybody likes unit tests, but then we remembered this is allowing an arbitrary object to be called, and it remembers the calls that are made. And it's got to be transparent. You don't opt in to being mockable. None of your objects have this mockable interface that says, yes, you can use me in a unit test, because that would be horrible. You've got to allow the mock to return specific values, because otherwise it's not really mocking. You're just kind of creating stubs. And again, you don't want to generate source or have client local interfaces or reflection, because you want to test the real objects, not some kind of generated thing. So do we notice that this is actually quite a similar set of requirements? So we went away and we thought about it. And so, well, what can we learn from unit testing? So what we learned was you can do pretty much the same thing they do. So to make an asynchronous call on a service, you need an async mediator. And you'll notice that that looks quite a lot like creating a mock. You can also use a service reference rather than the service object to create this thing, which is better if you're actually using it on an OSGi service, because then you can track availability, but you can mediate any object, even one you've just created in your own code. And then you use it to make a normal method call, and it's going to record that call just like a mock would have. So great, we've got this thing and it's recorded our call. Now what do we do? Well, what we do is we ask the async service to start doing the work. And you do that using call. And call can use the type of the value, the type that was returned by the method to give you a nice type-safe promise. And what you've got here is something where you've been able to make a call and then ask for it to happen asynchronously, and you have a promise to let you know when it's done. And we did the whole thing in 2 lines of code. Seems pretty clean to me. Void methods are a little trickier, and that's because void methods don't return a value. So what would you pass to async call? You can't pass void, it doesn't exist. So there's a no-args version, which just gives you a promise of question mark. But that's okay because a void method's not going to return you anything anyway, so the success value for a void method is actually just resolving a promise with null to say, yes, we're done, but there wasn't anything to give you. If you don't actually need the value that was being given, then you can do some fire and forget calls. So there's also an execute equivalent. So execute doesn't take a value because it doesn't return one, it doesn't need to know what it is. And it can be much more efficient, and we'll be talking about that later when I talk about some of the optimization work. So things to be aware of: the async service is thread safe, so absolutely fine, use it as much as you want on as many threads as you want, but the mediators aren't required to be, because there are different ways of implementing them, and some of them don't play nicely with threading. So you shouldn't share this async service between bundles, because it introduces security flaws potentially, and you shouldn't share mediator objects because they're not thread safe. On the other hand, if you use it just as a standard mediate, call, invoke, then everything's absolutely fine. So, quick example, we want to perform 2 long-running calls in parallel, and then we want to aggregate the result. So we get hold of our async service because we're going to need it. We also need to get the service that we want to call asynchronously. So this is effectively a DS component here, but I've omitted the annotations just to get it onto one slide. And then we've got this method getCombinedTotal. So getCombinedTotal is mediating this object, and then it's making an asynchronous call to count the number of bars in New York City. Then it's also counting the number of pianos in New York City. And what it's then going to do is it's going to flat map that value. Flat map is basically mapping but with a promise rather than a value. So it'll flat map and it'll say, okay, we want to flat map the value of the number of pianos and we want to add it to the mapped number of bars. And basically we're just doing addition there. But we've done, in that one line, we've had a single callback which is going to wait for both things to have finished and return us a nice single value which will tell us how many bars and pianos there are in New York City. So I said we'd talk a little bit about optimizing calls. So one of the reasons that we want to go async is typically that we want to get more out of our system than we can with standard sync programming. So, what if we can do better? So there's this thing called the async delegate interface, and it allows a service to provide its own async behavior. So to kind of get in the way and have the async service not necessarily do all the work. So remote services, as I said earlier, allows you to kind of transparently remote an OSGi service. But the details of this distribution are completely hidden from you. You don't know anything about them. So the distribution provider may support async communications, or it may not. But if it does, then it can probably do something slightly better than blocking a thread waiting for an RPC call to return. In fact, what it can probably do is take a call in and return a promise immediately, possibly even before the remote end has even worked out that there's a call happening. So you get entirely non-blocking behavior on the client without spinning a thread. Then at some point in the future, the answer will come back and we'll resolve the promise, and everybody's happy. But we were able to do that transparently under the covers because of this async delegate interface. We also talked about fire and forget. Well, actually, fire and forget is an even better case for optimization because it ignores the return value. So you've got no callback on completion, no return value, and this is the great place to be. If you're writing a remote call and the person doesn't need to know the answer and doesn't need to know when it's done, then what you can do is you can return immediately, send the request off, and then you're done. There's no return call, there's no network traffic. So you've significantly reduced the amount of work and the amount of load because you know that they don't care when it's done. So this is where you can get some real advantages with the async delegate interface. So now I'm just going to talk about, so we've got our system and we want to build it up from these asynchronous microservices. And when I say microservice, I usually mean OSGi service. I know other people can mean other things by it, but if you were at Neil's talk earlier in the week, you'll have seen there's a nice big list of the things you need to be a microservice. And actually OSGi services basically are. So, okay. So, as we've seen, if we want to build this thing, then the service itself can have a standard synchronous API. That's okay. You don't need to return a promise. You don't need some duplicate interface that does the same thing. You should have thread-safe or ideally immutable types for your arguments and your return value. But you were doing that already, weren't you? Everybody should do that. Basically, most APIs do work like this. Particularly anything that's remote, because remoting kind of relies on the fact that you don't have side effects, so these things are probably immutable, they should be serializable. So most OSGi services that have got a well-written API do this pretty well already. So you can use a mixture of sync and async because we've got the ability to have this service, call it synchronously or call it asynchronously. And then you can latch on it if you need to block until a certain state has happened with lots of promises. And I'd recommend you hold on to the promise rather than the value. And the reason is that that's actually a much easier way to handle your code. You don't need to have a state of, what if the promise hasn't resolved yet and I don't have the value yet? You just always register a callback, because if it's there, you'll get called back immediately. And if it's not, you'll get called back eventually. So where possible, make big calls into smaller calls and then aggregate them. So you can then even load balance across multiple machines, and you've got grid dispatch more or less for free. And you've got the whole try-catch failure logic handling, but you don't need to use a try-catch block. So everything can get much tidier, and failures aren't an afterthought. Failures are something that are intrinsic to the fact that you're doing this work. So you get a much tidier program out of it at the end. So I'm going to do a very quick demonstration, and what this is going to involve is me trying to do something live on the cloud. So let's see how we go. So what you can see here is the Service Fabric, which is a product I work on, and you can see we've got quite a few nodes. But the important thing is that we've got this fractal application, which at the moment isn't deployed. But if we deploy and just wait for that to show up, then what this is going to do is it's going to install a viewer, and it's this kind of RESTful service, which is using JAX-RS, and it's going to push work off to various different back-end workers. I've lost connectivity. This isn't good. Am I okay on EC2? So you always have two clouds. Yeah, that looks like it's responding okay. So, yeah, there we go. So DigitalOcean won't be getting paid by me today. Right, there we go. So here we are running on EC2 this time. And what we should find is that we can load, and we've got this viewer here. And what it's doing is, at the moment, this is synchronously rendering a Julia set. And you see it takes a while, and it's because each call is reasonably complicated, and it's been split up into chunks, but each call is happening synchronously, and so it takes quite a long time. And I know it takes a long time because it's just finished. But what we can do is we can do exactly the same set of calls, but we can run them asynchronously and just send the answer over to the client when each chunk is done. So what we can do is we can, let's change the color to make it even easier to see. I can zoom in, and you can see that asynchronously, that's filled in the data, and it does it a lot faster. And proof that it was asynchronous was you'll have seen all of the blocks came in kind of a random order. So that's pretty cool. But what we can do that's even better is we can actually load balance it. And what you'll say is, but Tim, that didn't really come in much faster. And that's because actually what we hadn't done was put in any workers. You'll see here this is red, and it's because we've actually said that we don't want any extra workers. So if what I do instead is I say we want 5 workers, and then we wait for them to start up, then actually we should find the whole thing goes much faster. So there we go, that's deployed 5 workers. Everybody likes a rainbow. So now, there we go. It's even faster, and you see it actually fills in much more randomly, and it's because we're spreading the work over lots of nodes, so we actually get answers back much faster. And we were able to do all of that because we had this, this async service that we could use. Now, just very quickly, I can wrap up. I know I'm probably slightly over time. So this is just so we were using the service fabric. It's a cloud runtime, and as you see, you've got dynamic deployment across lots of different pieces. And you can deploy all kinds of things, and I'm sure you've seen various people talking about it over the week. Actually, I skipped the important bit, which is, so this was just JAX-RS running in OSGi, Angular front end, so the kind of thing you'll see all over the place. It is using REST and server-sent events, which is why you can see the bits coming in a piece at a time. And we've got those scalable workers on the back end. So you can fan out automatically and get a lot of performance for effectively 0 effort. The source code is on GitHub, and there's a bit.ly link there, and that will remain up there more or less indefinitely. So if you want to see how the code's written, it's pretty simple really, and the difference between the sync and the async call is effectively a mediate, a call, and then a latch promise at the end to wait until everything's done. So, thank you very much for coming. If you do have questions, then feel free to ask. Also, if you would like to get a book about OSGi, then there is 44% off at manning.com at the moment, so feel free to use that. Otherwise, thank you very much for coming.
Just steal a few minutes of the lunchtime. I think everybody agrees on that. So, feel free to ask questions.
Yeah, okay, so one at the front.
So you said that you can use the library also outside of OSGi?
Yes.
But is it true that it is bound to Java 8, or can I also use it with
No, so the default implementation requires Java 5, but you could re-implement it on Java 4. In fact, you can re-implement it with quite a lot of different backends. So someone actually used the OSGi interfaces, but created an implementation based on Akka. So yeah, you're not tied to Java 8. Java 8 just makes the calls look nicer because you've got lambdas.
Is there any concept like pooling? I mean, like rejecting the execution exception when you saturate a pool or something like that? Or?
So if the async service is unable to make the call happen, it will fail the promise it gives back to you. So yes, you get failures and they come back to you through the promise and it will say why it failed. And one of the reasons might be the async service is stopping or the async service is overloaded. But so the implementation we have in our product, you've got a scalable thread pool that you can set the size of, and you can set depths for, and what you want the failure policy to be.
But do you have just one pool size for all this async management, or you have the capability of sort of like executors where you have to specify the pool size for each?
So that's down to the particular implementation. Again, we can have multiple pools, so different parts of the system can use different pools, or you can have a single central pool, or you can have a mixture of whatever you want. But it's down to how you configure it. It's an implementation detail. I think we had some questions further back. Yeah.
I wonder if there's any way to introspect which async services are going on in a particular moment.
So in terms of monitoring, again, that's going to be down to the implementation that you've got. So the reference implementation is pretty simple and doesn't give you a huge amount of detail. But if you want to monitor the queue depths in our management console, you can see how many things are currently queued and waiting. If you want, I can bring that up, but I should probably do that later. I don't think everybody is that interested in the depths of our admin console. Dan?
Tim, maybe you could be clearer on what is spec and what's implementation in ASYNC, because some of these questions seem to have this common theme.
Okay, so in terms of what is spec'd, you have the promise interface, success and failure callbacks, and the deferred. So that gives you a concrete implementation of a promise that you can use anywhere, and that's spec'd. Now there may be different implementations of it that offer slightly different backends, but fundamentally the promise behavior is spec'd. The async service interface and the behaviors that we talked about here are also all spec'd. So everything that's in this talk is exactly the letter of the spec. The things that aren't necessarily spec'd are things like the number of threads in your thread pool and how that's configured, how long your queue depths are, how you monitor those things. Those are down to the implementation, because it could be as simple as you don't have a queue, you just start a new thread for every task. That would be a perfectly valid implementation. It's not one I would necessarily choose to use, but it would be a perfectly valid implementation. So everything in the talk is spec'd. Some of the stuff in the questions about the more detailed monitoring stuff, then you need to look at your implementation. Okay?
What happens to a promise when the service is unregistered while the call is executing? And how is this different from the synchronous model?
So if the service is registered before the call starts, so you make an async call, and at that point it's going to be queued, and it may not start immediately because you don't know how much other work is going on in the async service. If the service is unregistered before the call starts, you will get a failure or a service exception of type async to say, yep, couldn't do that. And that's spec'd behavior. If you actually start the call and then the service is unregistered, then you're in the same situation that you would be with any service, which is if the service doesn't provide any safety about its destruction before and its unregistration, then it may start to destroy itself before the call's finished, and you'll get exactly the same failure you would in the sync case. So normally what you should do is you unregister the service, but you don't destroy your state until the last call that you were handling has exited, or you've given it a pretty big kick by interrupting it. Yeah?
Is it possible to distribute this approach, this asynchronous approach, like, I don't know, like Othercast does for a distributed callable?
So a distributed callable. Well, so you saw that the calls when we went to the load balance, those calls were actually running on remote setups. Yeah, you note that you don't give the async service a callable, you make a call on a service. So it will run wherever that service is based. So if that service is a remote service, it'll run remotely. If it's local, it will run locally. But that's where the load balancing that came in. So I didn't talk hugely about it because that is another thing that's in our product rather than a standard. But we have a load balancing service. There are lots of service implementations in the service registry. We make calls to the load balancer, and it just does round robin or weighted round robin across So that's how we're doing that. But yes, you can do it. And it's not even very hard. It's only a few hundred lines of code. Yeah? So the implementations of this spec, you have the reference implementation, and once we've got to the point where we've got a final a jar that we can start using in Apache, then I'll be putting together an implementation in Aries, and I imagine other people will come up with implementations fairly quickly. It's actually a pretty easy spec to implement, so the whole jar weighs in at something like 60K, including source code and including the promises implementation and its source code. So it's pretty lightweight, unless of course you want to start adding lots of monitoring stuff in, and then you can go kind of as big as you want. But a basic implementation is really small.
ECF is also implemented.
So what Peter was just saying was that ECF has also implemented this, which isn't quite true. So ECF has async behaviors, which they can put in, but they used a different method because they did it before the spec started. However, I believe that they're putting some work into using the async delegate so that they'll automatically fit in with. But it's not a huge amount of work. They're not very far away from where the API is now.
Tim, to be clear, the reference implementation for this is going to be in the Aries project and the Apache Software Foundation, correct?
Eventually.
That's what I'm saying. When we publish the spec.
Currently there is an RI in the OSGi repo because it was much easier to develop it there and get the CT running than it was to try and do the hops back and forth, given it's not a big project and there was no existing source code. But yes, the end goal is to have a public open source RI rather than the one in the repo.
So our conclusion is to get access to the implementation now, you should become OSGi members.
Right. and I have the forms.
So you can see all of this stuff. You can see all of this stuff up on GitHub, as I say. So you've got the stuff about the demo, and in terms of the source, it's all available in the public draft, which is not very old, and that's got all of the source code in there for the interfaces as well. So this is stuff that you really can start playing around with, and the final release is literally just around the corner.
Yeah, just for those people who haven't realized, there is a public draft was made available last Monday. So if you go to the OSGi website, you go to drafts, there is a public draft that is really, really fresh, and it has all the API and all the stuff.
Okay.
What is a monad in less than 10 words?
This is an async talk, so I'll get back to you.
Okay, well done.
So I think it's time for lunch now. We should thank Tim again for a very good presentation.